Alright guys, on to our fourth video. So now we're going to start talking about describing quantitative data with numbers. So the first thing I want to talk about is about this comparing mean and median when we were talking about our New York commuters and our North Carolina commuters. So it asks, think to our North Carolina commuters, what were their mean and median? Well, our mean was 22.5 and our median was 20. Now we think to our New York commuters, and it says what were their mean and median? Well, our New York mean was 26.5, and the median was 40. So then it asks, why did the New York have such a drastic change in their mean and median? Right? Notice how far apart these mean and medians are versus our North Carolina, which is just 2.5 minutes apart. And New York had a huge difference, 13.5 minutes. Well, why did this happen? Well, think back to your New York data, right? Our New York data had an outlier. There was one person who only took 5 minutes to travel to and from work, right? Where most people took closer to, 40 minutes or an hour to get there. So we had these outliers, and these outliers affected our mean drastically, right? The thing is that our mean is affected by any outliers that we have. But our median isn't, right? It's just the middle data point. So no matter if that point was a 5-minute commute or if it was a 20-minute commute, right? It still is going to be in the same place for our median because it's still in the lower half of the data. So that's important for us to remember that when we're looking at data, if there's outliers in our data set, right? They're going to affect the mean, and the mean may not be the best choice to use when talking about the center. Instead, we'll talk about the median because the median is not affected by those data. So we're saying that our mean is resistant to our outliers, right? Same thing as saying that our mean is resistant to our skew, right? No matter which way, if there's any skew, our median is the best choice to use. Well, when we're talking about spread, most often we're going to talk about range, right? Just subtract the smallest value from the largest value. And you've probably done that before. But we're also going to talk about something called the interquartile range. So to do that, we need to talk about quartiles. Quartiles separate our data into 4 equal parts. So we're breaking our data up into quarters. Our first quartile lies 1/4 of the way up of our list of data. Our second quartile is our median. It's halfway. And our third quartile is 3/4 of the way up our data. So to find our interquartile range, we're looking at the middle half of the data. So really what that means is we're taking our, We're taking our quartile 3, which we'll write as Q3, and we're subtracting our quartile 1, which we call Q1. So our interquartile range is just our range from the 75% mark to the 25% mark, because then we have the middle 50%, right? Because if we subtract those, that's our 50% of our data. So finding quartiles is similar to finding our median, right? We arrange our observations in order. And then our first quartile is the middle of the median. So we find the median first, and then we look at everything below the median, and from there, we can look at what's the middle or the median of that bottom half of the data, and that finds our quartile 1. It's the same thing for Q3, right? We're looking at the top half instead of the bottom half. But note, right, when our median is a number in the data set, we do not use that number to find the quartiles. When the median is not a number in the data set, we do use the middle numbers to find the quartiles. So if we had a data set like 4, 5, 6, 7, 8, right, 6 is our median. So that means we're looking at everything below that to find our quartile 1. So we would only be looking at this 4, 5, right? Finding the average, 4.5, would be our quartile. for our Q1. If we want to find our Q3, we're looking at everything above, right? Average that is 7.5. This would be our Q3 and our Q1. If our median is not in our data set though, right? So we have a data set of 4, 5, 6, 7, right? Our median is in between 5 and 6. It's 5.5. Well, we want to look at everything below our median of 5.5. So we would look at this 4, 5 to find our Q1. So again, it would be 4.5. And again, for above, we would look at everything above 5.5, which means we would include our 6, 7. So let's do another practice problem. Let's do it just with our North Carolina data. So here's our North Carolina data. We want to find our quartiles. First thing we need to do is find our median. So we need to put our data in order. So 5, 10, 10, 10, another 10, 12, 15, 20, 20, 25, 30, 40, 40, and 60. Now we can cross off on both ends until we get to the middle. That'll find us our median. Well, our median ends up being these two numbers, so we can find the average, which is 17.5. So there's our median. So remember to find Q1, we're looking at everything below our median of 17.5. So that means we're going to include that 15. And we're going to look at everything between 5 and that 15. And again, just like before, we're doing the same process we did for the median to find the Q1. So we're going to cross off on both sides until we get to the middle, which is 10. So our Q1 is 10. And then we can do the same thing for our Q3, but we're going to go up. So everything from that 20 and above, we're going to cross off until we find the middle. And we'll get 30. So our Q3 is 30. Well, once we're there, it's really easy to find our interquartile range, our IQR. Remember, it's just Q3 minus Q1, so 30 minus 10, which means we have an interquartile range of 20.